All right, so welcome back to another video. I was able to get a swim in today, so I do feel a lot better. Hopefully I can stay on track better than those last few videos. Gotta turn on my second monitor here though, if it would allow me to do that. Right now it is not. Okay, so second monitor is coming up. This video, we're going to continue to be working towards those goals in the last video. So I will share my screen and we'll take a look at what those goals are. So it's to learn about on-box scripts, OP, commit, event, and Snmp. So OP, our goal was to alert a server whenever a user logs into the box. I'm thinking that might be a bit too ambitious. I definitely don't want to work on things that aren't going to be on the test. And this is a test on Juniper, it's not a test on Linux. So if it comes to just learning how to configure a client on a Linux box to collect traps, I'm just not sure that's going to be a good use of my time. But yeah, let's look at the OP scripts. So here they are. So we can set a file. So we've already got test there. Great, so let's keep looking at the documentation here. Yeah, so this is on PyEZ. This isn't on box scripts. These are scripts that are not meant to be run on box. They're meant to be run remotely and then sent to the box over a SSH session. So you can see right here, we're establishing not an SSH session, but a netconf session, and then we're sending these down. So the following Junos PyEZ example, which uses Python 3, establishes a netconf session over SSH with the device running Junos OS and reboots all routing engines effective immediately. So we're trying to learn about on-box scripts here. So this is not going to be an on-box script. It's going to be a script that manages the device as if you would do manually through a terminal, but instead of that, it's going to use this module here to automate that, which is really valuable, especially on the job. It's really important to know that, but to pass the test, it's going to be more important that I stick to the curriculum. Okay, and this is the fourth video, so I'm almost tempted to just say, you know what, I gave it a try, and it wasn't enough. But let's do something here. So let's just open the guide. Yeah, so this is the automation scripting user guide. Let's open that. And then let's do expand all. And then let's search for example colon. Yep, and now let's pick out one of these examples. And we'll go through at least one of these, and then we'll move on to the next one. And this will be the last video in this topic. So this looks like a really good one. And this is a commit script. Yep, these are all commit scripts. Let's see if there's any examples for OP scripts. There are. Here we go. Change the configuration using Python OP scripts. Here we go, searching files. That looks like a good one too. Okay, so we've just got two more. We've got event options and we've got Snmp. Here we go. So here's event. So correlating events based on event attributes. Okay, so this last one looks decent. And here we go, Snmp trap. So that has Snmp in there. So I think these are all going to be enough. So here we go. We've got it for Snmp scripts as well. So yeah. Okay, so these are all the examples I'd like to use. So I'll add them to my notes. We'll add the tags as well. Oh yeah, I feel a lot better after swimming. Oh my God. Oh, did not know how badly I needed that. And the gym was all the people scanning in were behind protecting barriers and wearing masks. And I was wearing a mask too, which made it awkward because I couldn't hear the other person couldn't hear me, and we couldn't see each other's mouths either, so it was kind of awkward to communicate, but it wasn't too bad. All right. Oops. All right, so let's work through the first one now. First put it back to where it was. There we go. So this is generating persistent and transient configuration changes using commit scripts. Junos OS commit scripts enable users to customize the validation process of their configuration in accordance with their own practices and policies and enforce custom configuration rules during the commit process. This example demonstrates a commit script that generates a persistent change that adds the family MPLS statement in the configuration of the Sonnet/SDH interfaces when a statement is not already included in the configuration. If you do not explicitly configure the MPLS protocol family on an interface, the interface is not enabled for MPLS applications. The commit script in this example finds all Sonnet/SDH interfaces that have a logical interface configured, but that do not have the family MPLS statement configured. For these interfaces, the script adds the family MPLS statement to the interface configuration as a persistent change at the edit interfaces, interface name units, logical unit number, hierarchy level. The script shown is in Slacks, XLT, and Python. Okay, if they didn't have the Python, I was going to move on because the test is only on Python. Let's skip this paragraph because it looks like it's not talking about the Python. The Python version of the commit script generates the persistent change by issuing the jcs.emit_change function, which is imported from the JCS module. The Python script indicates that this is a persistent change by passing in the positional argument change. All right, so let's put this on the box. So we're going to go, we're not going to apply it to Sonnet interfaces, but we'll apply it to, how about GI01 and GI02? Or, well, that would be a Cisco, GE000 and 001. Let's do that. So let's find a way to type this out. It's going to need to go into the proper path. So if I do file list, we've got all these paths. So if I do file list USR, oops. Oh, USR. Yep, and then so I'm not sure where it needs to go. I think I can do a help apropos to find out. So I'm hoping they can tell me the file path that the script needs to go into. I have a feeling they will not, though. But if they do, that would really help me out. But it looks like they do not. Oops, so I gotta go back to my search because I'm just trying to find the file path on the Juniper where this script belongs. So what about basics? That sounds good. Ah, here we go, perfect. So it's going to be in var db scripts commit, if it's a commit script. Let's see what kind of script this is. Ah, so this is a commit script. All right, so let's go into that directory and then let's use vi to make that file. So start shell, cd, ls, see if there's any in there. Nope, so this is going to be the first one. And we're going to name it. Okay, so I don't see a naming here that is recommended. Ah, here we go. So it's going to be ENCIE-SP -ppp.py, which is an interesting name because I thought we were going to add. Okay, I thought we were going to add MPLS, is what it said up here, but I guess we're going to be adding PPP instead. I thought we were going to be adding family MPLS. Oh, okay, I see. So there's two of them. So yeah, we're going to be doing the MPLS.py one and not the PPP example. Okay, so let's just do a touch to make the file first. Okay, and now let's do CLI and follow the step-by-step. We're going to do configure private and then set system scripts, language Python, set system scripts, commit file MPLS .xsl. Oh, sorry, .py is what this one's going to be called. Okay. So now that file is going to run every time I do a commit. Well, right now there's nothing in that file, so I'm kind of doing things out of order. I definitely need to. It definitely would be better to create the file first, but it's not going to do anything anyway. So let's create the file now. Okay, so we're already in that directory. All right. Okay. Oh, okay. And so it looks like they're using a special Python character, this backslash here, because they want to put this on multiple lines. I'm not sure if that's the way I would have done it, but let's just follow exactly what they have. And if there's an error, we'll get experience with troubleshooting, which is always pretty valuable. Okay. So this is very clearly quite a bit different than the syntax for Python. That's because this is XML. It's what's used to make these configuration changes. Oh, so we're gonna have a little bit of a different message. So I'll just say to interface. Okay. All right. So we've got the command. So now it's only going to trigger if I have a family INET address on the interface. So let's put a description on the interface. So, actually, let's do a show configuration. Oh, the other thing is that, so interface starts with SO dash. So we got to change that because we're not going to apply this to those kinds of interfaces. We're going to apply it just to gigabit Ethernet interfaces. Oops, so definitely not a desired outcome. Oh, and now it's expecting me to do commands. Okay, it looks like now it's just changing the case of everything. So let's just try GE. Oops, so I'm not in edit mode. Okay, so now I appear to be in edit mode, but it's behaving strangely and just changing the case of everything, even though I am in edit mode. Okay, so I did not hit that sequence of characters. The exponent and question mark, I did not type that in, so I don't know why it thinks that I'm doing that. I just want to edit this file somehow. I can flip the case. So let's look up by. Yeah. So how am I actually flipping that case? Yeah. How am I actually doing this? So okay, so it just thinks I'm entering characters that I'm not. Just too bad. Because I just want to fix this up here. Yeah, I guess one thing I can do is just delete the whole line and then retype it. So I'll do D enter. There we go. So I deleted the whole line. I might have deleted 2 lines. Yep, I deleted 2 lines, but that's okay, I believe. So now I can do I, enter. Aha, now I'm in business. So let's do interface starts with name GE. Unit. Okay. All right, so everything looks good now. So if I just do a commit, I think it'll work now. Because so it didn't work. Let's see. Yeah, let's do a commit check. Pipe display XML. Okay, so let's do pipe display detail. All right, so the criteria here is if there's any GE interfaces, and there are. Yep, there's GE interfaces with INET on them. But they don't have family MPLS on them, which the script I thought, yeah, as far as I knew, it would add that on there. But it's not working that way. I wish it were, but it is not. Let's try doing a simple change. Okay, so aha, there we go. Yeah, if you just do a blank commit, you don't actually do anything, it will it won't trigger the scripts. I notice here it says SONE interface. So, oh yeah, because I didn't change this banner correctly. But we can see just really nice and easy. There's yep, really not too difficult. Can probably even find a way to delete that somehow, but it would just take a bit of digging. Oh, well, of course I could always roll back one, show pipe compare, just do a rollback 0. But yeah, you can see it's, yeah, so this one's done. I'm gonna take a short break here, and then I'll come back and we'll try to get through another one. If we don't get through them all, or we don't get through multiple ones, that's okay. We can just move on. It looks like this one doesn't have a Python script associated with it, so I'm going to skip this one. So let's take a look at this one instead. Okay, yep, so we got Python with this one, so I'm going to take a few minutes, and then I'll be back, and then we'll do the same thing we just did, but with this next script. All right, I'm back. So let's continue on with this new script. So let's see what kind of script it is. This is an OP script, perfect. So it's going to go into a different directory. So the OP directory for operational scripts. So let's see what the name of this script is meant to be. It's going to be config-change.py. All right. Oops. Okay. So this looks like an interactive script. All right, so let's give this one a shot. So it's an OP script. So there'll be instructions down here for how to run it. We're going to need to, yep, so we're going to need to manually trigger it. It's not like a commit script where it's based on some action on the device. The action that triggers it is OP and then specifying it. So these are the scripts that could be really, really valuable, and that during the test could really help me out, these OP scripts. But let's, yeah, I think it might be a little bit too much though. I think I'm, as of now, just planning to manually configure everything. I think adding the complexity of scripting it out, you know, it might help, but might not as well. So let's do, yep, so let's do the step-by-step. These are OP scripts. Okay, so we already have this enabled Python. Yep. So I'm just gonna commit and quit. All right, so now I'll do op config change.py. Okay, now we get to choose which interface to disable. Let's disable JE006. Okay, so yeah, this is really good news. So one thing I've been wanting to do that I think would really help on the test is create a way I can use the help menu better. So I might be able to use this as a guide. So yeah, having this right here as a template, I think might work for me. So yeah, and then I see, so this script allows a user to make better use of the built-in help, built-in help. So please enter search phrase. Okay, so then what we can do but of course we're not going to need to go into config mode. We're just going to need to do a open. So yeah, where we imported config here, we won't need that. We'll need whatever allows us to just simply send the command. So we've got, yep, but this is for config. So what else is there besides config? We've got start shell, util. So this is the utils, and config is there. What's start shell? The Juno shell. Okay, I think this start shell might work. I'm not sure what they mean by shell, if they mean so if they mean this shell here, or if they mean if you do start shell like this and then you get a shell like this. I'm not sure what they mean because both are Juno shells, so I don't know which. So it looks like CSH is what it would be. So let's take a look at what that is. So it would be this shell. So yeah, that's not going to be a good enough shell. Yep. Definitely not the shell that is required. So let's see if there's other modules. Yeah, let's go up one level. So .device. Got a init, autoprobe, open. All right. Here we go. So this looks better. .cfg. That looks good. What about fax? Okay, so this you just get back stuff that's configured on it. I want to get back something about help. I don't see anything about help. Yeah, I don't know if it's a good idea to go down this rabbit hole again. Let's see, what was I looking at? So I did the OP scripts. Oh yeah, I already did that. Oh, so yeah, I selected one to disable. So let's do a show in terse, pipe match, GE dash. And yep, we can see this is now down. Okay, so let's just move on to the next one. I will keep these two help things open because I think that would be really valuable to figure out how that works, but it's not the most important thing. Okay, so this one doesn't have a Python script, so I'm going to skip this. Okay, so non-standard. Reference a kernel system log message in an event policy. The raise trap action in the then statement is executed only if a kernel event containing a message that matches exited on signal 11 occurs. Okay, so I can just go through this, type it all out, but I won't commit the changes. So it's going to be edit, event options, policy, kernel policy, set events. So we've got all kinds of events to choose from, but we're going to choose KERNEL, and then edit attributes match, set KERNEL dot message matches exited on signal 11, set then raise trap. Okay, so let's do a commit check, but then afterwards a rollback 0. Okay, so we won't commit that, but yeah, let's consider that done and move on to the next one. This is raising an Snmp trap in response to an event. Okay, perfect. Yeah, this one looks really good. So the following example configures the event policy raise trap on OSPF neighbor down to trigger the RPD OSPF neighbor down event, which indicates a terminated OSPF agency with a neighboring router. The event policy raises a trap in response to the event. the device sends a notification to the SNMP manager if one is configured under the Edit SNMP hierarchy level. Additionally, the event policy executes the event script ospf.xsl in response to this event and provides the affected interface as an argument to the script. The $RPD OSPF neighbor down, that interface name argument resolves to the interface name associated with the triggering event. The event script output is recorded in the file ospf-out, and the output file is uploaded to the destination mgmt-archives, which is configured at the edit event options destinations hierarchy level. To invoke an event script in an event policy, the event script must be present in the var db scripts event directory on the hard disk, and it must be enabled in the configuration. Okay, so let's just add this configuration on there. So we're not going to be having this event script because there's no instructions for setting that up, but let's just get it in our fingers, get used to going into that hierarchy level in Junos OS, just so we know it exists, we have some sort of sense of what it does and what options are available. So if it comes up on the test, it won't be for the first time. So here's from before, we've got a bunch of events to choose from. This one is going to be RPD, OSPF, NBR, DOWN. Okay, so everything looks good. Let's do a commit check. Oh, so yep, of course, this is going to be, so destination is not defined. So I don't see how to define the destination, but that is going to be required. So let's see, edit event options, set, now is there, yeah, destinations, perfect. So it's going to be MGMT, ARCHIVS, oops. Archive sites. Okay. All right. So I would have to actually give a URL of destination for where it's going to send these. So I'll forgo that, and I'll do the rollback 0 now, and I'll move on. All right. So this next one is just the boilerplate for SNMP scripts. So let's look at the Python boilerplate. All you need is this JCS. Python SNMP scripts do not have a required boilerplate, but they must import any objects that are used in the script. Python SNMP scripts must include the import JCS statement in order to use the get_SNMP_action, get SNMP OID, emit SNMP attributes functions that retrieve the action and OID values passed to the script and return the data for the requested MIB object. Python automation scripts do not need to include an interpreter directive line at the start of the script. However, the program will still execute correctly if one is present. Okay. All right, last one, and then I will be ending the video here. So this is processing unsupported OIDs with an SNMP script. So yep, and we got Python on this. So let's type out this whole thing just to get under our fingers a better sense of how this is going to look. And then that will be it for today. Okay, so let's go back and let's see if there's, yep, so there's a folder for Snmp. Okay, so what's the file name for this? This is going to be sample_snmp.py. All right. Oops. Thinking about upgrading my chair. This is just I think it was like, it couldn't have been more than 50 bucks. I think it was a $50 chair from IKEA, which, I mean, it's not bad. It does what I need it to do, pretty much, which would allow me to be comfortable for long periods of time. But of course, I don't want to get too comfortable because just sitting all day is really bad for you. So I do have a standing desk, and I want to kind of switch between sitting and standing. But at the same time, it's actually doing a pretty darn good job of the criteria of not being too comfortable. So I think I'm just going to switch to standing right now because my body is aching a little bit. Come on. Okay, there we go. And now I'll be able to finish this out and move on. So syslog 8. Oops, a bit too high. All right, so yep, that's good. So if Snmp action hits, if Snmp OID 1.3.6.1.26.36.13.61.1.9.1.1.1. Okay, so now the elif statement. Oh, and I'm forgetting a leading dot in the other one, so I'm going to need to fix that before I finish this. So this is, but this one's going to be, oops, and this is not accurate because I need to include an elif under this nested if here. You know what? This is just a little bit too much, typing. I don't think it's necessary for me to do. It's just going to be kind of a waste of time. So I think I'm going to call this video done here. I don't really see any benefit with typing that out. I do like this read the docs here for PyEC, so I'm going to include this in my notes. Okay, and then this will be the last video in this topic, so I'll go ahead and mark it as done. So yep, so this on box, this is going to be it. So I'll rename it to done. Then I'll go back to automation scripts and rename that to done. Perfect. Okay, so we've just got one more topic left, and that's going to be interface configuration and troubleshooting. Not really sure what that's all about. I definitely understand how to configure interfaces and troubleshoot them. Something I've done quite a bit, so I might hopefully make a pretty short video on that and then move on to IGPs. So thanks for watching, and I'll see you in the next one.